Hey,
Hey,
hey there, hi there, ho there.
Hey, hey.
am I coming through loud enough for the audience? Because somebody just commented saying the volume was low.
No, I can hear you nice and clear.
Yeah, here. Okay.
Yeah.
All right. Well, let's go with that. So, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show.
Hey.
First of all, I'd like to welcome back my two regular co-hosts, Mr. Paul Owen from the Moonshot Observatory in beautiful Hampton. Paul, good evening, sir. And also Mr. Mike Powell from the PFO Observatory right here in St. John. Hey, Mike.
Hello.
All
Hello.
right. On tonight's episode, we're pleased to welcome back our storyteller and stargazer extraordinaire, Curt Nason, who will guide us through a look at Pisces, a prominent constellation in our southern sky at this time of year. Curt calls his presentation Pisces with a twist of lemon sauce. Welcome back, Curt.
Thank you. Thank you very much. Well, thank you very much.
Thank you.
I know I don't talk like this normally, but I have to do because it's a show, right? So,
Yeah,
Is it? Okay.
yeah.
I mean, people are watching?
not many right now, but maybe.
We've got 6 million viewers.
Someday, I keep hoping.
We've got
Uh,
six.
uh, Also tonight, Mike, who's going to return with another binocular target of the week. Paul brings us another interesting Rosanna's fun fact and another segment from the book Night Watch. And also, I'm going to offer a little bit of a look at what's up this week. And of course, I'll have your photo submissions to share. So sit back and enjoy, everybody. And remember, this is a live, family-friendly, interactive broadcast, family-friendly. So keep the comments friendly and fan. And let's get started. Mr. Nason, sir.
Oh, that's me, is it?
Here.
All the way down. There we go.
Well, try to make it family, but times do change. Let's see. Linda. There you go. There he is. Yeah, if I can only find. Okay, it is up. Yeah, does that work? Yep. Okay, here we are, Pisces. Now here it is up here. Pisces the fishes, and it's surrounded by Pegasus up here. You got Andromeda just above it. A whole bunch of constellations around here: Triangulum, Aries, Cetus. Over here is Aquarius. So this is an autumn constellation, and there are two sets of autumn constellations, and one of them is the water constellations, which emanate here from Aquarius is pouring all this water out. You have a lot of water-related critters out here. Something you don't often see here is a sea goat. We have a dolphin up in here, a fish down in here, a whale here, and we get a couple of fish over here, which is Pisces. Now, I was about 8 or 9 years old and getting interested in the constellations. I'd be looking at the newspapers. I think we both had the Gleaner and the Telegraph were coming, and they had that astrology column in there. But to me, it was just constellations that I was seeing and reading the things about it. But Pisces was maybe a favorite of mine because I didn't know how to pronounce it. So when you're 8 or 9 years old, you see something that's called Pisces, well, you sort of giggle a bit and like that. Much in the same way I was hoping for the Pittsburgh Pirates in the 1960 World Series until I got corrected on that one. So we've got in here, we have Saturn, which is right in that same area now, and it will be within that area for another year or two as it moves slowly around the sun. And let's take a look here at, well, I'll tell you one of the stories about it first. Right in the, this Pisces goes back about 6,000 years in Babylonia and get picked up by the Greeks after that and then the Romans. And usually the most common story about this was you had the Olympian gods and goddesses, and they were always in battle with their half brothers and sisters, the Titans, who were mostly giants, things like that. The most ferocious of the Titans was Typhon, the giant. Now he could live in through fire. They had the four elements. They get earth, water, or earth, fire, and wind, but he couldn't live in water. Right. So the Olympians were having a party picnic there at the side of, well, one place said seashore, another says it's the Euphrates River. And as they're having their good time there, come roaring out at them was Typhon. And they wanted to get away because it was very mighty. And the Olympians could change their shapes into anything they wanted. So they're going to change into fish and jump into the water to get away from Typhon. Now we have Aphrodite and her son Eros, or in Roman it was Venus and Cupid. And you've got them here, represented by the fish here. They're going to change into fish, but they didn't want to get separated when they get in the water. So they took the time out to take a cord and tie their ankles together, and then they jumped in as fish. And they got away from the Typhon that way. And to commemorate that event, it's Athena that put the two fish up into the sky to commemorate that. And when you look over here at Capricornus, an origin of that one bears from that same incident. That's from the god Pan, half boy, half goat. Now, when he saw the Typhon, he panicked. It didn't completely change into a fish. So that's why you see the tail of a fish here and the head of a goat. All right, so constellation borders are really odd. You might expect them to be like nice circles and things like that. But for hundreds of years, they had thousands of years, they had constellations. There's really no set borders for them. So a lot of the constellations were sharing stars and things like that and overlapping each other. Right, but it's about a century ago, the International Astronomical Union had Eugène Deport, and he got together all the constellations. They settled on 88 of them take up the entire sky. And he spent 2 or 3 years assigning borders to these because you wanted to keep a lot of these had stars named based on the constellation. And some other things would have had names based on related to the constellation. So we tried to get them all so you wouldn't be all screwed up like that. So with Pisces here, maybe you can't see it as well, but comes up here, starts up here around just up in this area, up in Andromeda, comes around, cuts off a bit over here and down in here, comes down this way, over this way, down around Pegasus, and way down here like this. So make very angular because these are all made to go along lines of declination or right ascension. So that's why you got all these little blocks in there like that. All right, so when you look in here, you can see that the Saturn is not quite in the borders of Pisces at the moment. It had been earlier this year, but when the Saturn is approaching opposition, maybe a couple of months before it reached opposition, it started retrograde motion, which took it back into Aquarius. And now it's doing prograde again now. And probably within a week or two, it'll be moving here back into Pisces. And it'll stay in Pisces up, the ecliptic going up this way toward Aries. So it'll probably stay in Pisces for, I think, another year or two. All right, it takes about 30 years to go around, so that's about 12 degrees per year, roughly, for Saturn moving across the sky. And you see this little mark in here. Looks like a ram's head, which it is. This is the astrological constellation, or the astrological sign for Aries, the ram. They call this the first point of Aries. This is where the ecliptic and the celestial equator join. So when they join at two parts, these will be both the vernal equinox in spring and the autumnal equinox in fall. So even though this happens now in the constellation Pisces, with astrology, this is always where the sign of Aries starts, and it goes for 30 degrees in this way, then you're into the sign of Taurus, and 30 degrees, and so on from that. So they're completely different things. All right, so it's been in Pisces for quite a while now. You see the dates in, say, the horoscopes and the telescope. A few thousand years ago, when these were developed, the vernal equinox would have been in Aries, like that. So when did it become part of Pisces, according to the current borders of Pisces? So we go back to about 55 BCE. That's about the time that Julius Caesar becoming emperor. And this is about when it's heading into Pisces in here. And it will stay in that for a couple of thousand years, but you saw where it is now, getting very close to Aquarius. And we look at this, it'll be about 550 years when the vernal equinox moves into the constellation of Aquarius. And maybe that's when they have the dreaded or long-awaited age of Aquarius. I guess it was based on that. Hopefully I'll be dead and I won't have to hear the song. Okay. So I told you the main fish tale there about Aphrodite and Eros. It's Greco-Roman. There's an old one from the Germanic areas there from a guy called Adante. And he and his wife were very, very poor, and they had just a cabin on the seashore, apparently, and their only possession was a tub, and the tub was filled with feathers, and I guess maybe that was their bed. And very, very simple folk. He'd be out fishing, and so fishing one day, and he cast his net, and he caught this fish that really, really gave him a hard time to land, and he struggled with it for quite a while. And he finally got it up on shore, and he figured, this is a really strong fish. I really don't want to keep that. So he takes the fish and puts it back in the water. And then the fish starts to talk to him. Apparently it was a prince, and just maybe changed into a fish. And the prince fish there had said, just to reward you, for being nice and putting me back in there, tell me anything you want, and you shall have it. Well, he said, well, I don't really want anything. He said, I'm a simple person. I don't need anything at all. So he walked away. And when he told his wife that story, she got mad at him and said, you idiot, we could have anything we want. He said, I'd love to have a beautiful house with great furniture in it. Get out there and find that fish again. So off he goes and he's on the seashore and calls to the fish, and the fish comes up and he tells him, well, my wife wants a beautiful house with nice furniture in it. He said, go back to your house and see. So we went back up there, and there, lo and behold, there's a beautiful house, and went in, and his wife was very happy, and there's great furniture there. But it didn't take long that she got a little bit greedy, and she said, we can probably get anything we want. I'd love to be a queen in more than a palace. So she sends him off again, and calls the fish up, and the fish comes up, and what can I do for you? And he said, well, my wife wants to be a queen and have a beautiful palace. He said, go back to your house and see. Gets back there, and there's his wife. She's now a queen, and there's a beautiful palace. And that keeps her happy for a while, and then she's looking for more and more. She says, I want to be a goddess. Go back and tell him that. Okay, so he goes back and calls the fish again. Says, my wife wants to be a goddess now. And the fish had had enough. That's asking a little bit too much. So he took away everything that they had before, and they're left with pretty much nothing. And just as they were previously. I guess the moral of the story of that is just don't get greedy. But when you're looking at the constellations around there, some people think with this story that tub that they had was probably the square of Pegasus, and was filled with feathers there from just beyond Pegasus is Cygnus the swan. And maybe the feathers came from that one. There's the two fishes there. Let's see. One here and one up in here. Now, in some areas, this is drawn this way, but there's actually a circle of stars in here, just like there is in here. So that other one, this is the northern fish, which we just showed you, that is drawn there with a triangle. In Arab countries, that was called swallow's head. The other fish is called the western fish. You have north and west. So that's the directions they're heading. All right, so since Christ was born in, well, maybe 7 BC, 6 BC, probably 5 BC, that would have been, the sun would have been in Pisces at that time. All right, and so the fish has become a symbol of Christianity, and we see it here. And there's a lot of things going on in the church that were related to the fish, and they had fishermen back then as well, although I guess Christ and others were carpenters. So when you see things like this is an index. This is the Greek letter chi, which would stand for Christ, not again CH. All right, so when you see things like Xmas, some people complain that, well, it's taken Christ out of Christmas, but it isn't. That's not an X. It's a chi. And here's the astrological symbol for Pisces. And this is the Christian fish in here. So a lot of things in the church, in the different churches that relate to Pisces, even if they pronounce it correctly. So we look at the stars here in Pisces. Its main one is called the Alpha Piscium. It's Alresha, and it's called the cord. Now, where Aphrodite and Eros had tied their ankles together to jump into the water, that's where that star is in the constellation. It means the cord. And it's not really bright. It's in magnitude 3.62, 310 light years away. It's a close binary star, somewhat difficult, 1.8 arc seconds apart. Now there's Beta Piscium, which Fumo Samaka, which means mouth of the fish. And it's quite dim, 4.48. You might barely see it here from maybe in St. John, at least in the suburbs of it. Now, actually, the actual brightest star in Pisces is Eta, which is quite well down the alphabet. It's called Alphyrg, officially by the International Astronomical Union, and is just slightly brighter than Alresha, right? These are binary stars there. So the combined one, I think that this one is 3.62. If you look just at the alpha one here for Alphyrg, it's actually 3.61, just slightly brighter than Alresha. The gamma star is 3.7, and the delta star 4.4. So most of the ones you see along the making up the main part of Pisces are dimmer than fourth magnitude, or between 4 and 5. Now there's one other star, and it's called Van Manen star. This is number 2, or Van Manen 2, or Van Manen star. Turns out it's the closest single white dwarf to the sun. That's at 14.1 light years away. Now, closest single one is the word here, because we have the white dwarf that's a companion of Ceres, which is only 8.6 light years away, and Procyon in Canis Minor, it has a dwarf companion, or a white dwarf as well, or a companion star, and it's about 11.4 light years away, or 11.2 in that area. So this one here in the Van Manen star, it's not part of a double. It's just by itself. And it's about 2 degrees south of Delta, and it's magnitude 12.3. So, with a decent sky, 6 to 8 inch telescope, you can pick it up. And now, where are these stars here? All right, so here's the sky and telescope when you get to see the pocket guide. All right, so here's Alresha in here, see where the 2 fishes are joined together. And the beta star up in here, just off the end of the head of the western fish. Right, gamma is very close to it. It's actually part of the circlet of Pisces in here. It's the westernmost star of that little circle. Right, delta is up in this area, just above the head of the northern fish, and Eta is down here. So Van Manen star be just down in about this place here, a couple of degrees south of the delta star. And Eta in here, which is the brightest star, that constellation is in here. Right, and we'll see them be a good jumping off point for something we'll come up against here. All right, for asterisms, so we have the circlet of Pisces, very well known. In China, the northern circlet was seen as the house of Sandal, and the line of stars from Alpha to Delta. Okay, so there's the house of Sandal. This line of stars up along here was seen in China as Weiping. It's a fence to farmers to keep them falling into a marsh. I think they're pig farmers, and maybe the pigs are there. And in 1754, the British botanist and his author, John Hill, like several other people around that century, they would maybe make themselves a little more famous by filling in some blank parts of the sky and making up their own constellations. and several of them have now become official constellations by Hevelius and a couple of other guys. But he put one in between Cetus and Pisces called the Tortoise. So in here, of course, that looks just like a tortoise, I guess. Maybe I can't see it. Maybe it's under the water, but tortoises are land turtles. They don't go into the water. All right, so one person picked that up and added it into his map, but he's the only one. And eventually, nobody else had used it, so it's just sort of fell out of use very quickly. So they're the main asterisms you can see in Pisces. Now, for deep sky objects, there's one Messier object, M74, the Phantom Galaxy. All right, so since the vernal equinox is in Pisces, that's where the right ascension begins at 0. So right ascension runs east. So this one is going to be east of the vernal equinox because it's at 1 hour, 37 minutes there. All right, 15 degrees above the equator, magnitude 9.4. And it's NGC 628, and we can see it in here. That's the only one that we can see. So here's M74 in here, and see a bright star here. That is that brightest star in Pisces. That's the Eta star. You can't pick out that. Maybe you can jump off from Hamilton to Sheraton here in Aries and go over that direction and pick up that star there. All right, so M74 is a noted one in springtime when we do say late March to early April when people do their Messier marathons. I've tried this for several years. I get well along in one of them, then we had a snowstorm hit us, rapidly trying to tear down telescopes. Okay, so M74 down in here, this is the one you have to get first because it's off into the west just after sunset. You probably have to pick this one up in twilight, which can be very difficult. Right? Be easier if you're doing it in say in March, because once you get into April, it's moving closer and closer to the horizon. And a lot of time you can get that one. The really more difficult one is M77 over here in Cetus. All right, so this would be the last one people would pick up. And from here in New Brunswick, it's virtually impossible to pick that one out of twilight. I know Paul Gray and Ted Dunphy and Don Kelly did a marathon 20 years ago at Ted's place, Dorn Ridge. Paul got 109, Ted 108, and Don I think had 103. And Paul was in that area, couldn't make out M77. So it's pretty much impossible. All right, looking at other ones here in the deep sky gems, we have 4 of those listed. These are by David Levy, and he picked 100 and some of his favorite top 400 of the NGCs. So we have NGC 472 in here, 11.5 magnitude galaxy. And it's this one here, because this is NGC 470, which I believe is, nope, not that one. 470 is a nice telescope, nice one to pick up, a brighter one. So that one's right beside it. 488 in here. It's an elongated 10.2 magnitude. 514 down in here. Back to 11.7, but apparently it's easily seen. And 11.7 NGC 718 down in here. All right, actually it takes us right through to the end of that. So I did add a few things in here because not a lot to see in Pisces. So rapidly I'll go through something in here. I'm just wondering, when you look at this part of the sky, could this have been inspiration for Theodorus Geisel? He's a famous writer, poet. Right? He sold over 600 million books. He passed away in 1991. Very famous, and a lot of his books are poetry. And you might not recognize the name. He went by a pen name, which is based on his middle initial there. But I'd like to maybe read part of one of his more famous poems. One fish, two fish, red fish, blue fish, blackfish, bluefish, old fish, new fish. There's one fish down in here, Pisces astrinus. We have two fish up in here. Redfish, bluefish. Well, we have red stars and blue stars out there. This one has a little car. Well, there's a car, C-A-R, Capricornus. This one has a little star, and every one of these would have them. See what a lot of fish there are. Yes, some are red and some are blue, some are old and some are new. Some are sad and some are glad, and some are very, very bad. Well, see this here, he's playing the ugly sea monster that ready to devour Andromeda in the Greek legend. Why are they sad and glad and bad? I do not know. Go ask your dad. Some are thin and some are fat. The fat one has a yellow hat. From there to here and here to there, funny things are everywhere. Here are some who like to run. They run for fun in the hot, hot sun. Oh me, oh my, oh me, oh my. What a lot of funny things go by. Some have 2 feet. Some have 4. Well, there's one with 4. Some have 6 and some have more. Where did they come from? I can't say, but I bet they have come a long, long way. We see them come, we see them go. Some are fast and some are slow. Some are high and some are low. Not one of them is like another. Don't ask us why. Go ask your mother. All right, so a lot of things in there. So maybe that inspired Dr. Zeus. And that asks Zeus what his mother's maiden name. And his middle name was Zeus. Or Zeus.
Cool.
So that leads into Pisces astrinus, which we'll add in here. All right. Some places, some maps have it upside down like this, or back toward the south. Some have it back toward the north. And when you look at all this, the mouth is taking in all the water here. And some stories have it that fish is the one that drank up all the water during the Great Flood with Noah's Ark and things like that. So that's where all the water went. The fish took it. In Egyptian mythology, the nasty god Set killed his brother Osiris and cut his body up into several pieces and dispersed him. Now, Osiris's wife and sister, Isis, collected all the pieces together, except for one piece, which is a very odd part of the body to lose like that. It went in, thrown into the river, and apparently a fish ate it. And there's a fish in Egypt called an Ostracous, and you see that is the one that ate that body part of specific body part of Osiris, and that fish is celebrated now as more of a fish that sacred fish to the Egyptians. There are no deep sky objects here, but it does have a very famous star, this brightest star, Fomalhaut, which is up in here in the eye, right? And that's not the cord. Okay, that's a fish's mouth, right? I doctored up the one from the previous slides there, and I didn't get that in there right. I'll have to fix that one. But it's magnitude 1.16, which makes it the 17th brightest star in the sky. Some places will say it's the 18th. When I got this from the RASC handbook, and in their top 50 bright stars there, they're looking at single stars. Before, if you've got maybe 2 stars or 3 stars and your combined light would be brighter than that, then some places would make that number 17 and Fomalhaut number 18. But if you're looking at just the single star, it's the 17th brightest. Close binary, well, okay, that's one I didn't fix either. It's often called the lonely star or the solitary one because when you see it in the sky, it's all by itself. It's the first magnitude star, but there's really no bright stars anywhere near it. And that name also goes to Alphard in Hydra. It's a bright star that's more off by itself as well. All right, so Fomalhaut is one of the Persian royal stars, the Watcher of the South. The rest of them, Regulus was the Watcher of the North, Aldebaran for the East, and Antares for the West. In Arab countries, they had a folk name for it. Fomalhaut was the first frog, and the second frog was Difta, which is in Cetus. And coincidentally, if you want to find or verify Fomalhaut, you look at the 2 stars on the western side of the square of Pegasus, and they point directly down to Fomalhaut. Now, the two stars on the eastern side, they point directly down to Difta. And it was thought that Fomalhaut and Castor and Vega and 13 other stars were actually a moving group. Just like most of the stars, say in Ursa Major, except for the two, one in the end and one on the top of the one at the Dubhe at the top of the bowl. They aren't part of this moving group, and several other ones in there. But once they get better measurements of it, through the Gaia satellite, they realized that these aren't really all moving in the same direction, and they're not actually the same ages. So it's not really a moving group. All right, there's an exoplanet discovered around Fomalhaut, and it's going to show you a picture there. But it was the first, it was around 2008, and it's the first one that they would actually get a photo of. There's this big dust disk around the star, and there's a patch in there that they thought was a planet. And so in 2015, when they started giving names to exoplanets, the first one they named was Dagon. And that was an old, Fomalhaut was a very famous star, important star for the Syrians long ago. And one of the Syrian gods was called Dagon. But around 2016, they realized there's not really a star in there. As they got better measurements, and later on, they realized that dense patch that was in there was fading away. So it wasn't really an exoplanet. This is a picture of what they have there, the disk going around it. And these could go up to maybe close to 140, 150 astronomical units away. And so big star like that is going to be bigger disk. That's maybe their equivalent of the Kuiper belt in around there. Right, so got all that dust in there. There's a thicker part in there that I'm not sure what that is. They know it's just a dusty area in there. And there's the little black hole in there. It's not actually a black hole. It's where they're blocking out the light from the star so they can get that. So if you really want to know, is there actually an exoplanet around this, don't ask us. Go ask your mother. And that's the fish scissors.
I'm going to go swimming with the fishes.
Little fishies, swimming in them.
When you started talking about dismembering here, Curt, I was just about to cut you off. Here we go again. I tell them every time, can't give kids nightmares, but no. But anyway, thanks, Curt.
Wasn't anything scary in that one, was there?
No.
Another one, 101.
Yeah.
Scary enough.
Okay, thank you, sir. Paul, do you think you still want to do your night watch talk, or you want to?
Yeah, it's really short.
Okay.
Yeah. So
We'll go with that first.
Things up and running here. Hang on.
Can you guys hear me okay?
Yeah.
I guess maybe the audience can too now, maybe. You guys could anyway before. I don't know why the audience
Yeah, we're a lot closer to you.
This is true.
Crap.
That's true.
There you go.
Maybe.
There it is.
If somebody can comment from the audience, just to let me know that my sound is better. Thank you.
Okay. All right. So tonight's little chat from the Night Watch book that everybody should be getting for Christmas. If you already don't have it, if you do have it, keep yours and buy one for somebody else. Great Christmas gift. Anyway, tonight's little excerpt from the Night Watch book. I'm just going to share my screen. Figure out how to do that maybe. Window. There we go. You see it okay?
See something?
All right. So this is just page or chapter 3, and this is on the celestial works. And this, just for those who don't know where we are on Earth and what we might see depending on where we are on Earth, this is helpful Polaris. So Polaris is that little tiny dot you see right up there, just above that observatory. That would be Polaris. So the further north you are, the higher Polaris is in the sky. In fact, the height of Polaris is an indicator of your geographic latitude. For example, if you live anywhere on the 40th parallel, you'll see Polaris 40 degrees, Polaris, not Polarius, Polaris 40 degrees above the northern horizon. Almost half of your visible sky is circumpolar. If Polaris is 66 degrees high, you're standing on the Arctic Circle, and most of the night sky is circumpolar. If Polaris is directly overhead, you're at the North Pole, 90 degrees north latitude. From here, all stars are circumpolar, none rise or set, and during the long, dark Arctic winter, the entire northern celestial hemisphere is visible at a glance. So the situation is very different in the south. Viewed from the southernmost Hawaii, Polaris is a mere 20 degrees above the horizon, and less than a quarter of the sky is circumpolar. Even the Big Dipper rises and sets. If you're just north of Quito, Ecuador, latitude 0, Polaris lies very near the northern horizon, and none of the stars are circumpolar. At any given time, half the northern sky and half the southern sky are visible. Over the course of a year, every constellation rolls into view. So if you look at these two little pictures, the ones that the actual illustrations. So basically, if Polaris is straight up overhead, then the celestial, you're kind of at the celestial. Oh, there we are. Yeah. So Polaris is straight up overhead. Then straight out to your left and to your right would be the celestial equator. So in the Arctic sky, for example, at Earth's North Pole, you see Polaris at the zenith. The zenith means straight up, and which would be right here. The celestial equator would be on the horizon, which we see right here. And all visible, and all the northern constellations are all visible, and none of the southern. So the stars are never, and the stars never rise or set. Now, if we just scooch down to the equatorial sky, at the observing site on the Earth's equator, Polaris lies on the northern horizon. So instead of Polaris being overhead, it would be right over here, right on the horizon. So Polaris lies on the northern horizon. So the celestial equator arches across the zenith. Half of the northern celestial hemisphere and half of the southern are visible at the same time. And so again, there's our little buddy, and that will be the equator. So there, Polaris would be right here. So just to give you an idea where that is, I'm going to stop sharing for a moment. Where did we stop sharing at? There we go. And if I don't know if you can pin me or not, Chris, but if you want to know where that is on our Earth, so okay, so here's North America. This is where we are. So we're quite a ways up, going to the North Pole. So you can see that the equator is a long ways down. So even when we go to our little places in the sun in the winter, lots of times they're just around this area. And even that being the case, you're still not at the equator. You have to actually be pretty much in the northern part of South America. If you keep going all the way around, it also cuts right through Africa. Well, there, because I probably weren't seeing that. So right through Africa. So that line that goes right around the center, that itself is the equator. So if you can get there, then things change drastically in the night sky. And then the further south you go, the less you see of course, of what we see. So anyway, so I just want to kind of show that for those who don't know a little bit about where we are in relation to and what we see in the nighttime sky and why we see what we see. But anyway, that's chapter 3 in the Night Watch series. And again, for those who are just starting out that don't know a lot about this stuff, it's a great book to learn from. For those who do know a fair bit about this stuff, it's a great refresher. So that's it. That's my talk for the Night Watch book this week.
Awesome, Paul. Thank you, sir.
Okay.
And I can see out of the sun pin thing. Unpinned. Here we go. Okay, we're back. All right. How about a Bino Bud quickly? We're running into time here.
Binocular target of the week this week with Bino Bud is the double cluster. And I forgot the cartoon.
Yeah.
Anyway, double cluster, also known as Caldwell 14, consists of open clusters NGC 869 and NGC 884, which are close together in the constellation Perseus. Both visible with naked eye, NGC 869 and 884, lie at a distance of about 7,500 light years. How would I find it in the sky? Well, we all done this. There's a beautiful target on a nice night to look up. But at 2300, orient yourself 50 degrees northwest. Look pretty much straight up. The double cluster's right over your head. You can't miss it. It's this time of year, it's going straight over, so it's not hard to find. If you look at Cassiopeia and come down from the W on the way to Perseus, it's about halfway. Right, come down off of these two stars, these two here, and it'll point right to it like an arrow. And it's not hard to find at all. What does it look like? Well, there's an image I took of it. So, two beautiful clusters stand right out. You can't miss it when you sweep your binoculars across it. You'll know you're on the double cluster. In 10 by 50s, again, nice and big and bright, real easy to see. Beautiful target. I don't think I've ever seen the whole thing in a telescope, but I can see the whole thing in a pair of binoculars. Compared to the full moon, I'd say each cluster is about the size of a full moon, so at least 2 full moons, if nothing else. So nice, big, bright target, easy to see. Get your binoculars out, go have a look. And how did the space teddy bear cross the road? He walked.
Oh, no.
Oh, yeah. That's target of the week by Bud Oh Bud. He walked. He didn't run.
Curt, what do you think of that one? Because that would be like yours. That would be close.
Pardon me?
Oh, you can't hear me now. The volume's down again.
You walking, you talking.
All right.
That's pretty
Thanks,
good.
Mike.
That's pretty good.
Let's move on to Rosanna's fun fact.
All right, let's just see if we can make it all happen here. Number one. Come on now. Share. And this is this week's. Well, hey, welcome back, Rosanna, to another wonderful fun fact. And now to get right into it, just got to get my information in front of my face. There we go. Okay, so this week, Rosanna writes, "Hi, Paul. Have you ever had a person or perhaps an animal accidentally or sometimes deliberately photobomb your pictures?" Next, I'll get right into the photos because this is important to see. There we go. This happened to me while visiting Ministers Island, and now I have this random tour guide guy in a lot of my photos. It could be funny, but the next picture must be one of the best photobombs in astronomy. Discovered in January 2025, Comet Lemon made its closest approach to Earth in October when amateur astrophotographer Ellison captured this photo from Kananakal in Turkey. The little pinwheel galaxy, also called NGC 3184, peeked out from behind the comet from a distance of nearly 40 million light years. So there he is right there. There's a comet going by. Great photobomb in my estimation. And a happy Canadian news story, Canada is increasing its contributions to the European Space Agency. The Canadian government announced this week that it will expand its investment in ESA programs by 528 million Canadian dollars, a tenfold increase compared to the previous contributions. Canada is not the only Canada is the only non-European partner in the European Space Agency, an arrangement that dates back to some 1979. Now, how to tell there's a Canadian aboard the ESA Space Rider? Oh boy, I can see about a dozen Tim Horton franchises from here. You appreciate that, Mike. And now for something else in the news. Now let's see if I can press the right button here first. There we go. And this is interesting. This is really interesting. So at first, I thought this report was an AI fabrication. Then I rather fervently hoped it was, but alas, it is the real deal. So take a look at this. So what this is Ben Nowak and tons of mirrors is solving solar energy's nighttime problem. his idea and companies started gaining attention in 2024 and is now gaining investors and traction with the planning of launching constellations of mirror satellites to illuminate and solar power our towns, countrysides, and anywhere you can imagine on the earth during the nighttime. A major selling feature is to the agricultural world, promising quicker crop growth and thus more profit. The idea is actually even older. There is a paper from NASA from 1982. The paper also quoted and listed on the Reflect Orbitals research search page. So that would be the study there from 1982. Now, here's a little bit more from the website itself. So, although at first rather, the majority thought that this was a boondoggle of an idea and not possible, and there are some YouTube debunking videos on the very improbable chance of success, NASA released this on October 22nd. So this little thing, if you haven't read it, so it says energy is evolving, becoming smarter, more sustainable, and endlessly accessible. Using a constellation of in-space reflectors, we are redirecting sunlight precisely when and where it's needed. Experience a smarter way to power your world. And then it goes on and talks about a few things there. So let's move on to the next slide. So 4,000 orbital mirrors could catastrophically brighten night sky, astronomers warn. Now, Reflect Orbital's plans to deploy 4,000 orbital mirrors reflecting sunlight to Earth alarms and astronomers and ecologists fearing catastrophic light pollution impacts. California startup Reflect Orbital applied for the FCC authorization to launch EARENDIL, I would think that would be Erindil, 1 in April 2026. A demonstration satellite deploying 18 by 18 meter mirrors reflecting sunlight to a 5-kilometer ground areas. The company envisions 4,000 satellite constellations by the year 2030, providing light on demand for solar power extension and emergency illumination. Astronomers warn the system producing beams 4 times brighter than the full moon would catastrophically increase light pollution, disrupting astronomy, wildlife, circadian rhythms, and nocturnal ecosystems, all already degraded by 10% each year through artificial illumination growth. Now, the curious ambition of space-based solar reflection. So Reflect Orbital's sun synchronous constellation at 550 to 600 kilometer altitude would track the terminator, which is the day-night boundary on Earth, maintaining continuous solar visibility while passing over twilight regions, delivering concentrated sunlight to customers requiring extended daylight hours. Each 18-meter mirror achieves a greater than 300 square meters effective area, concentrating sunlight into a 5-kilometer diameter spots, reaching luminous levels comparable to civil twilight, according to the company projections. The 1.25 million USAF SBIR contract validates potential military application, including forward operating base illumination, disaster relief, lighting, and extending solar farm generation into morning, evening peak demand windows when electricity prices strike. Over 250,000 service applications suggest market demand, though company revenue models remain undisclosed. We can make that a little bigger. There we go. So what happens when artificial stars cross observatory fields? So the 18-meter mirror at 550 kilometers altitude subtends greater than 3.5 arc seconds, appearing as magnitude -8 to -10 artificial star, comparable to a crescent moon brightness to ground observers within 100 kilometers of the beam center. So unlike Starlink satellites creating brief streaks during twilight passes, reflect orbital mirrors maintain continuous illumination while tracking targets potentially dwelling 2 to 5 minutes over a 5 kilometer footprint, moving some 7 kilometers a second orbital velocity. John Barentine calculates atmospheric scattering distributes 10 to 30% of reflected flux across 50 to 100 kilometer radius, elevating sky brightness by zero point 0.1 to 1 magnitude during passes, sufficient to degrade photometric calibration, saturate wide field survey detectors, and compromise time domain astronomy detecting transient events requiring dark skies. So why it matters for astronomy and dark sky preserves. Let me just move ahead. Oh, wrong one. Hold on there. There we go. So ground-based optical astronomy already faces existential threats from satellite constellations. 6,000 plus Starlink satellites create 20,000 plus streaks per night across Vera Rubin Observatory's 3.2 gigapixel camera, with 100,000 plus satellites projected by the year 2030. So Reflect Orbital's 4,000 mirrors add quantitatively different pollution, active directed illumination rather than passive reflection, fundamentally brightening nighttime sky rather than incidentally contaminating exposures. Robert Massey emphasizes that physiological distinction. SpaceX implements mitigation, dark sat coatings, reducing brightness by a factor of 2 to 4. But Reflect Orbital's core business model requires maximizing reflectivity, making mitigation incompatible with service delivery. International Astronomical Union's CPS-1 Dark Sky Protection Committee estimates 4,000 mirror constellation would render 30 to 40% of professional observatories unable to conduct planned science, concentrating impacts on low altitude sites near terminator regions where mirrors preferentially operate. So, having said all that, wow, I wish the Reflect Orbital just as much success as this next idea. And this is the inconvenience stores. And that is this week's. Try it here. There we go, Rosanna. Thank you so much. That is so disheartening when you think about something like that, because it's all about money and how the corporate world could increase the greed. And look what it's going to do to the night sky. So I'm hoping this thing just falls off to the side and it doesn't really go anywhere. So that's my opinion.
One way to solve the daylight savings time problem.
Yeah, there you go. Isn't that wild?
Well, you just pay for a year's time to point the mirrors directly at the CEO's house.
Yeah, that's what it's exactly.
Like,
yeah.
what if you're like trespass then, right? So I'm
Yeah.
within a 5 kilometer, the smallest area that you can service. Like, who's within that 5 kilometers says I don't want this, and you're trespassing now.
Yeah.
Lawsuit,
Yeah.
lawsuit.
Yeah. Anyway, it's that's where it's at now. But I mean, this idea has been floating since the early '80s. So.
Or even before, probably. Yeah, that's crazy.
Yeah. I guess when people think about money, they don't think about a lot of other things. So there you have it.
That's
Anyway,
right.
Rosanna, that is absolutely interesting, and I did not know anything about that. So I'm going to do a little more research on that one.
Awesome. Okay, let's get to some photos really quickly. And yes, thank you, Rosanna. That was kind of disturbing. Not as disturbing as Curt talking about dismembering the.
Yeah, what's going on with you guys?
Yeah, come on, it's a family show.
This is a happy, family-friendly show. No, and it still is.
Yeah,
I didn't mention any particular body parts.
True, you didn't. Okay, let me get this over here. let's get over here. Hang on, folks. Bear with me. Oh, this one. There we go. Okay. Let me share my screen first of all to you guys, and then I'll bring in the audience.
There we go.
There we go. Okay.
Whoop,
And
there
this
it is.
There it is. Okay, let's start it with this one. This is from David Smard. David says, hi, this morning at 3 a.m. the sky opened up for me. First object was M1. Grab nebula, of course, just to get the scope aligned. And then he says, where's he? C2025K1 comet.
Yeah.
There you go.
There you go.
Very nice.
Should get better, but she is still pretty, he says. Then C2025T1. This one.
Here it is. Yep.
Does not really have much of a tail. She's at magnitude 9.3, and it was close to us on the 14th of November, he says. And then that last one was 3I Atlas, the interstellar comet discovered by.
There.
Bit of a tail.
Yep.
Yep. Aliens, aliens, run for your lives. Anyway, looks like a comet to me.
It does to me too.
Yeah.
Nice work,
All right.
David.
Nice work, David. And I think you have one more here, M76. Yeah.
Oh, nice.
Yeah, crop the image just a bit so we can see more detail. So nicely done.
There it is. Yeah.
Yeah, good stuff, David. Thank you.
That looks good.
I'm going to switch over now to Francois Theriault's capture here. He says, Chris, please find attached a suggested image for the show. I processed a Horsehead Nebula in narrowband. Here's my write-up. IC 434, the Horsehead in Nebula, in NGC 2024, the Flame Nebula in narrowband. I decided to try something different. Assemble the narrowband images of the Horsehead Nebula in an OHS combination instead of the traditional SHO. Please remember that the colors are only there to help visualize the interactions between the different gases and understand the physical processes taking place. Rules are sometimes there to be broken. True enough. The Horsehead Nebula is in fact a dark molecular cloud obstructing the bright emission nebula in the background, while the Flame Nebula is in itself an emission nebula, gas excited by ultraviolet radiation from a central star. Both are part of the Orion Belt complex. I would say probably one of the most photographed spots in the whole sky, right?
Yeah.
Especially through the winter.
Yeah.
Surprisingly, the bright star Alnitak, which is also associated with this region, is actually in front of the gas clouds, therefore not physically interacting with the two nebula. This telescope was a Explore Scientific 80 EDCF, focal length of 480. Camera was in ZWO ASI 1600mm Pro, and total exposure time 16.2 hours.
Yeah. Well, there you go. That blue really shows up what typically would be red.
Yeah.
And but you can see it. Yeah, you can really see the difference in there. How it separates from the other things. That's pretty cool.
Pretty cool.
Yeah.
Thanks, Francois. I was in there and I grabbed a couple more from him. He does know about these ones, but anyway, I got them anyway. when I go on the hunt and you see me a picture, I might go find some more. This one says M33, the Triangulum Galaxy, of course. A spectacular spiral galaxy in the constellation of Triangulum, next door to its big sister, the Andromeda Galaxy. It appears to us in a 3/4 view, tilted at 54 degrees with respect to us. Well worth the effort, he says. A nice visual target as well. It is too. I spent 3 nights imaging this nice target to get sufficient data to do it justice. Same telescope as before, same camera as before, and now we're up to 8.7 hours of integration time.
Very nice.
Very nice.
Lots of nice
Beautiful.
detail. Good stuff, Francois.
Yeah. Good work.
One final one from him, this one. LBN7, the Gecko Nebula. He said, in fact, the Gecko is a molecular cloud in front of the Great Lacerda Nebula, a very faint emission nebula in the constellation of Lacerda, which appropriately means the lizard. I can see that.
Wow. Yeah.
This being a very faint target requires significant capture and integration time. I dedicated over 5 hours so far, certainly a target to revisit this winter to add capture time to it. Exposure, same camera, and a total of 3.8 hours. That's pretty cool.
Yeah. I like that one right from the get-go.
Oh boy. Let's get off air here. Let's get off air here pretty quick. It's going downhill.
You're gonna be running.
That's nice. That kind of
Yeah.
stuff you got to spend a lot of time on to bring that stuff out. So
Yeah,
I
beautiful.
mean, just in 5 hours, he's got a lot. So I can imagine he put a little more time into this one.
Yep,
Crazy.
awesome.
Very nice.
All right, this one comes from Chris Benoit, Cygnus Wall, a North American nebula.
There you go.
Yes,
About 1
sir.
hour.
Where's that, Chris?
update. I have no idea. But 1 hour data with the C-Star S50. Awesome.
There you go.
Good stuff, Chris.
Very nice.
And a couple here from Kathy Adams. Last night we had a brief clear window for imaging. She said, I will combine more data when I get another clear night, hopefully soon. I got maybe 90 minutes on each target before one hid behind the trees and the clouds came in and hid the second one. So
Yeah, it's a nice rosette. Very nice.
rosette there, and
Yeah.
she's got a really nice
Oh,
triangle
good.
in there too. Yeah,
Yep, you got M33 as well.
Yeah, beautiful.
good job.
Very nice.
Thanks, Kathy. And if you have any images you'd like to share, we'd like to put them up on our show, so you can send them in to astronomybythebay@gmail.com, and we'll be happy to put them up on the next broadcast. Absolutely. Quickly look at what's happening this week. Is it tomorrow? Tuesday morning. Mercury and Venus are going to end up in the early morning sky just before sunrise, so they're going to be tough, are they not, Curt, to catch?
For me?
I say they're going to be a little bit tough to catch, are they not?
Well, Venus is still fairly easy to see if you're out there. So
Yeah.
Mercury, I think, is actually 1.5 to 2, something like that. So it could be difficult.
Yeah. Well, less than 2 degrees apart on this day, and then 3 degrees apart the following day. So Tuesday, Wednesday of this week, 6:55. I'm saying here, and sunrise is around 7:30. So I'm not far away from it. So anyway, give it a try. Why not? You're going to be up anyway. Everybody is anyway, right? So first quarter moon arrives on Friday at 2:58 a.m. Atlantic time. First quarter moon rises around noon. It's highest at sunset, and it sets near midnight. So lots of things to catch out on the moon with the Terminator line where it is there.
Yeah.
So,
There was a nice thin crescent last night.
mm,
I was heading out. It was just gorgeous.
also that night we have the lunar straight wall, which is a 110-kilometer fault line on the moon. It's visible the same day or the day after first quarter. So it's on Friday evening here. This picture comes from Lisa Fanning from Lisa's Lookup, and she's captured it there. Well, so it's just a fault line that really changes with the shadows. It's really a trick of shadows on light shadows on the moon. It's really just a gentle slope.
Yeah.
It looks like a big cliff.
Looks like a sword to me.
Does.
Toothpick.
Okay. And I think we're coming to the end. Saturday, the moon greets Saturn. Waxing gibbous moon. We're in the evening sky. We're looking at this is a view through 10 by 50 binoculars, so you should be able to pick it out pretty easily. Moon and Saturn is always nice to have together. For sure.
Yeah.
Okay, I'll stop sharing here. And I'm just gonna. Oh, hang on. I was going to share something else. Over here. They did have a couple. Hang on.
Going through the jasmines of my mind.
Where's my here it is. Two final things to share here.
All right.
Which was this one, of course,
Oh yes.
which is from Lisa. So this is the chart that Lisa puts out every month for us. It comes from Lisa's Lookup, Astronomy and More. She puts out this chart for, this one's from November, right down to the end there, getting close now. She lists the event, the date, the peak time for the event, and seeing tools that you require, naked eye, binoculars, or telescope. And you can find Lisa at Ruby Moonbeams on Instagram, Mastodon, Facebook, Threads, and Alan Blue Sky. Thank you, Lisa. And finally, the calendar that our man Curt here puts together for us, the 6-week calendar. We're getting a little ways along in that one too. You can find this calendar at sjastronomy.ca. You can download it right there for free. Yay! So keeps you posted on what's happening.
Free is always good.
Free's always good, every time. Okay,
Yeah.
I just need to get my closing thing going here. So talk amongst yourselves for a second.
Max, get my clothes.
There you go.
Now
I
it's
think we're
time. Okay.
There we go. There
Okay.
we go.
Are we at the end? I think we are. Yeah, hey. There we are.
Yeah.
Okay. So, in closing then tonight, we wish to extend a special thanks to Curt for joining us again. Thank you, Curt.
Sorry it took so long, but maybe I'll come back.
You'll be back.
Okay.
Thanks for that excellent talk. Okay. Remember, too, we do love getting your photos, so send them in to astronomybythebay@gmail.com, and we'll be happy to put them up on our next broadcast. And we're always looking for suggestions for other shows, so let us know. Send it into the same address. Let us know what you'd like us to talk about. Please let your friends and family know, too, that we are here every Sunday night at 8 p.m. on Facebook and YouTube to entertain you with astronomy and the wonders of the night sky. So for now, then, from Mike, Paul, Curt, me, wishing you all lots of clear skies. As we like to say, guys, open your eyes to view the skies and keep your scopes. Point it up. Good night, everyone.